Hi everyone, I will present our paper about unsupervised video-based remote physiological measurement with spatial-temporal contrast. Video-based remote physiological measurement is to use subtle color and motion change in facial videos to measure some physiological signals, and in this work, we will focus on remote photoplethysmography. As shown in the left video, rPPG is a blood volume variation which causes subtle skin color change in facial videos. Most work use supervised method, which is to use facial video and the corresponding ground truth physiological signal to train the rPPG measurement model. But the problem is that it is expensive to obtain the ground truth physiological signal measured by contact sensors and synchronized with facial videos. In this work, we try to use only facial video to train rPPG measurement model, since facial videos are very easy to obtain in large amounts. But the challenge is how to train an rPPG model without ground truth physiological signals. And in this work, we will try to incorporate rPPG prior knowledge into the model to enable unsupervised method. I will introduce 4 observations about rPPG as our prior knowledge. The first one is the rPPG spatial similarity. The heart pumps the blood to the whole body, so the blood volume change is the most consistent in different body areas. So, in different facial areas, we will get similar rPPG waveforms and similar power spectral densities and similar heart rates. The second observation is the rPPG temporal similarity. The heart rate doesn't change rapidly in a short term. In different small windows from a short rPPG clip, we will get the similar PSDs and similar heart rates. The third observation is cross-video rPPG dissimilarity. rPPG signals from different facial videos have different PSDs. Since 2 different videos are recorded with different people and different physiological states. For example, some videos are recorded before and after exercises, and some videos are recorded in different emotion status. So this will cause different heart rates and heart rate variabilities, so that different PSDs are in different facial videos. And in the left figure, we show the most similar and most different cross-video PSD pairs. We can see that the most different thing between 2 videos is the heart rate peaks. The last observation about rPPG is the heart rate range constraint. The heart rate range for most people is between 40 and 250 beats per minute, so we will only use the PSDs in this interval. For our method, the first step is to get the spatial temporal rPPG block. The ST-rPPG block is a collection of rPPG signals in spatial temporal dimensions. After obtaining ST-rPPG block, we will do spatial temporal sampling. For spatial sampling, we can get the rPPG signal at one spatial position. For temporal sampling, we can randomly sample a short time interval. Finally, we will get multiple rPPG samples from the ST-rPPG block. Here is our overall diagram. We have 2 different videos randomly chosen from a dataset as input. For one video, we can get one ST-rPPG block and a set of rPPG samples and the corresponding PSDs. For another videos, we can get the similar things. And then we use the contrast-Phys laws to learn the rPPG information. We put together PSDs from the same video for rPPG spatial temporal similarity. We push away PSD from the different videos for cross-video rPPG dissimilarity. The figure shows that the rPPG waveform from our unsupervised method is very similar to the ground truth PPG signal, even though the model is not trained with the ground truth signals. We compared our unsupervised method with the traditional rPPG method, supervised method, and another unsupervised baseline. Our proposed method surpasses the previous unsupervised baseline, and also most approach the supervised rPPG methods, and the results are consistent on all 4 datasets. Here are some saliency maps. The saliency maps for our method focus and activate most skin areas, where the maps for the unsupervised baseline show messy patterns and only partially cover facial areas. That's all my presentation. Thanks for watching.